Okay, so FRQ number 2, we looked at FRQ number 1 earlier this week. That was function concepts. In FRQ number 2, we're going to be looking at modeling a non-periodic context. FRQ number 2 will always be of the same structure. It will always require a graphing calculator, and it will always have 3 parts that focus on content from units 1 and 2. It will always be presented in a real-world context. You will be asked to work, possibly asked to work with polynomial, piecewise defined, exponential, or logarithmic functions. In part A, you'll also be asked to construct a function model by building a system of equations. In part B, you'll work with average rates of change. And part C, you'll justify a conclusion about the model. The total points will always be out of 6. Now, FRQ number 2 will always be broken up in this way. The question stem will present a verbal description of a context. You will have to extract information from the verbal description, and the stem may or may not include a table. Looking at these ones over here. The function types that we'll be looking at will be polynomial, mainly linear or quadratic, a cubic possibly, or you could have a piecewise defined function, which could have a mixture of different function types, exponential, or logarithmic. Different things that you'll need to do on your calculator. You should be able to store values. So we're going to be storing quite a number of values today. So I'll be going back and showing you how to store values. We've seen it before, but we're going to review how to store values. And you're going to store those values that you'll need to use multiple times in your calculator. Because remember, you do not want to use a decimal approximation for something you're calculating with. You give the decimal approximation to 3 decimal places at the final answer, not with any intermediary computations. So you want to retain the full value for any subsequent use. So storing is going to be your friend. Storing functions, storing values. Part A is going to be worth 2 points. And there's going to be 2 parts, part I and II. And they'll have the structure presented in the sample that we'll look at right now. It's going to be a max of 4 parameters, A, B, C, and D, that you'll have to find depending on the type of function. And it'll be 1 point for equations and 1 point for the values, as we'll see when we get to the sample. Now, one thing, as we'll talk about more when we get into the sample, we are finding a function model given data points. We can either find the function model by hand, using system of equations or other things that we know, or if it is applicable, we can use a regression. That could be a linear regression, a quadratic regression, a logarithmic regression, exponential regression. Any of those could be potentially useful for us to be able to find our model. Part B is going to have 3 points, and all parts are going to focus on the average rate of change. I pointed that out in our key concepts packet. And the things that we're going to have to do is calculate the average rate of change, apply or interpret, and reason. Those are the 3 parts. And the calculator is most helpful in part I. Part C will be a 1 point part, and it focuses on a limitation or assumption of the model, like when the model is appropriate to use or when the function breaks down. And questions could focus on domain or range. So let's go ahead and turn the page and jump into the sample that we have. So just like on FRQ number 2, I have the sample FRQ with the point breakdown on the side. As we go through these, I'll kind of give different explanations on the different parts. I want you to go ahead and take a minute or so to read through the problem, kind of maybe underline or highlight different key parts that you feel are important. Look at what we will have to do for part A, I, and II, and think about how we could move forward. So we'll go ahead and check in a minute or two after you've done that. So let's go ahead and look at this. So we're talking about students who completed a class, then participated in a year-long study to see how much content from the class they retained following the year. So that'd be like you guys. We just, we're completing the year of pre-calculus, and next year you decide to participate in a study to see how much pre-calculus you remember over the course of the year. Sounds fun and exciting, right? I thought so. Everybody's jumping up and saying, yes, I want to do this. So, it says at the end of the class, students completed an initial test to determine the group's content knowledge. At that time, t equals 0, the group achieved a score of 75. I'd say that's probably an important piece of information right there. So at t equals 0, we had an average score of 75. For the next 12 months, they were evaluated at the end of each month to track the retention. And after 3 months, so t equals 3, we have a score of 70.84. Then it tells us the group score can be modeled by the function r. So then we have this. So that's an important piece of information. There's our function model. So now we know we are using a logarithmic. They told us that we could be potentially a polynomial, piecewise, logarithmic, or exponential. And they've given us a logarithmic model here. And it says where r of t is the score in points for month t, and t is the number of months since the initial test. So it says use the given data to write two equations that can be used to find the values of a and b. Now, even if you don't know how to find a and b, you should be able to write these equations. So, what I would recommend is we write down the information that we have. So we have some different t, r of t values. And then our model is going to be r of t equals a plus b natural log of t plus 1. So we have 2 points here, 2 values. What is the first t value that they give us? 0. What is the r of t, the score at 0? Okay. What's the next point? 3, 70.84. Again, 75, 70.84 are the r of t values. Using these, we are now going to write, they want specifically 2 equations. So literally we just plug in the information and write 2 equations from the 2 points. Let's see, it's r of t equals a plus b natural log of t plus 1. What's the first r of t value? So we write 75. Remember, we don't know a and b, so we just write a and b. What's the first t value? So 0 plus 1. There's our first equation. We got one of the 2. Write the second one. Brandon, what would be my second equation? There we go. That's it. We just earned a point. 1 out of 6, right there. Pretty doable, right? Okay. Part 2, find the values of A and B. Now, for part A and B, or to find values of A and B for part 2 here, we can do this by hand, or we can use a regression. This one you have to be very, very careful about using a regression. And the reason why is that in a regression, the function that you get is actually y equals a plus b natural log. Okay, that's looking pretty similar. Then it's actually natural log of just x, not x plus 1. So you have to adjust your t values of 0 and 3 to make it work. So we're going to do it a different way first. And you could use a full system of equations using the elimination method. But one thing, and it's been a little while since we've done logarithms, but whenever we graphed logarithms, we always had the same point on every single parent graph. Do we remember what that is? 1, 0. That point right here. So no matter what your base is, what is log of 1? What is log of 1 regardless of the base? 0. Okay? Always. And notice what happens in this first equation. What do we have right here? Natural log of 1. And what would be natural log of 1? 0, automatically. Okay? That is something that you want to make sure you remember. It will help you go through this quicker. Obviously, you could have plugged natural log of 1 into the calculator, gotten 0, but if we recognize that, you're like, hey, this makes my life easier. I'm going to go ahead and use that fact. So I'm going to go ahead and take that first equation. So 75 equals a plus b natural log, and that is natural log of 1, but what did we just say natural log of 1 is equal to? So that's b times 0. Well, what's anything times 0? And what are we left with? A equals 75. We just found one of our values that we wanted. Again, just knowing that little feature of our logarithmic functions. Every single logarithmic function, regardless of what the base is, has the point 1, 0. Always. Now, using that, in the second equation, 70.84, we now know that a is 75. We are now going to solve for our b value. That's natural log of 4. I want you to see where you can get, see if you can find your b value now. All right. Let's go ahead and see what we have. Dean, what would we do first? What was that? I would leave it just ln of 4 because then you will have a decimal approximation, and remember we don't want to use that, so I would leave it as natural log of 4 for right now. What was that? Isolate, and so what would we do? Definitely subtract 75. I'll get back to color green. It's minus 75. What does that give us? 4.16. Okay. Equals b times the natural log of 4. And then what would we want to do to get b by itself? I'd still leave it as it is. Yeah, just to be safe. I'll not subtract. It's dividing because we're multiplying. So divide by the natural log of 4. Because remember, I can plug all that into my calculator. So I have b equals to 4.16 divided by natural log of 4, and that's what I would plug into my calculator. and then store it. So let's go ahead and do that. So go ahead and get that down, start plugging that into your calculator. Let's get that B value. And remember, you always want to round to 3 decimal places. 3 decimal places. All right, let's see. Using that, Zach, what did you get for your B value? So I want you to go all the way to those 3 decimal places. Negative 3.000, and then what was after that third 0? 80, so there's an 8. Remember, we want to round to 3 decimal places, so I would not write that as negative 3. We would want to write it as negative 3.001. Okay? Now, if it was 000 like 2, I would still, just to be safe, because whenever we give a decimal approximation, we want 3 decimal places, I would write negative 3.000, just to be safe. Okay? So that is negative 3.001. Now let's go ahead and write the equation then, the equation that we're going to be using. So that would be R of t. They don't ask for it, but I'm going to go ahead and write it. So R of t is equal to A was 75 minus 3.001 natural log of t plus 1. That is our equation. Now I want to show you how to store things again. Remind ourselves how we store. Because we are going to be utilizing this equation in our average rate of change. So I would recommend that we put this equation into y1 and our y equals, or y vars. However, I would not type it in as we see it there. We want all the decimal places for b. Now that would be pretty tedious to have to type out all those decimal places. So this is again where we were talking about storing the values. So let's remind ourselves how we store values. So let's go to the calculator. Let's see, let's clear that out. I have it in there already, but I'm going to clear it out. Let's see. All right, so we did define our B value. We did 4.16 divided by the natural log of 4. That's what we had, right? We entered, we got that value. What do I have wrong? Something's wrong there, because that should be negative. Oh, you're right. Negative there and over here. Good job for catching that. All right, so let me do that again. So negative 4.16 divided by natural log of 4. Now it's negative, okay? And again, I don't want to have to type all those decimal places out. I don't even want to have to write them all out. So we are instead going to use the calculator's memory. Do we remember how to store? What button do we press? The thing above the on button, right? The STO with the arrow. On the Casio, it's an arrow button. Let's go ahead and put books away right now. We're not doing other things. We need to be focused on what we're doing here. So we are going to take that value and I'm going to store. So I just hit the store button. And what was that letter that this represented? What was it, A or B? Was this our A or B value? This was B. So then let's store it in B. Makes sense? So I go that store button, and then I'm going to go alpha, and the apps button to get my B, and I'm going to store it in the B. So now anytime I use the letter B, it will have that value. If I store something else in B, obviously the B value will change, but for right now, B is that value. Which then allows me in y equals to type in 75 plus B, instead of having to type all that out, negative 3.0008 whatever, I'm able to just say b and the natural log of x plus 1. Too many parentheses there, delete, there we go. So if you store your b value, then we can use it here. I'd recommend similar type of things. Before we move on with that, I want to show you with this problem. This could have been done with regressions. But the problem is, again, like I mentioned earlier, the regression is going to be an a plus b natural log of just x. And if we have just x, and I try to have 0 as x, well, again, thinking about this, what is the natural log, or what is any logarithm at 0? What do we have right here? Do we remember the graph? It's all along up and down our y-axis. An asymptote, yes, because this goes down that way. You have a vertical asymptote. So if you try to do a regression like you see it, without adjusting things, you're going to get an error, and then you'll be very confused. So what you are going to have to do if you choose to do a regression for this problem, the two on the homework actually work with regressions as they stand. You don't have to adjust anything. But this one does need to be adjusted. And so instead of 0 and 3, we are going to do the 1 and 4 that we get when we plug it in. So let me show you that. So if I go to Stats, Edit, I enter in the information like this. So instead of 0.75, 370.84, I want to do 175, 470.84. I have to make that little adjustment. Again, this is why I would recommend doing this one by hand instead, but I do want to show you we can use the regression. So once you have your points in, we go to calculate, and then natural log regression is number 9. It's number 9, and I'm going to go ahead and store it. I already have my one that I have from earlier in y1, so I'm going to do y2 instead. Are these the same a and b values that we had previously? Yes? Yes. Okay. But again, notice, like I said, it's a plus b natural log of just x. So if I wanted to utilize this, if this is the way I went around it, I would need to adjust my equation to have the x plus 1. So I'd have to go down here and go all the way over here and change that to plus 1. And now those two equations are identical. Okay? But again, hopefully we just have this one y1 there, the 75 plus b natural log of x plus 1. But if you do run into one later on in the two practice problems that I have after this one, and you want to try regression, regression will work without having to adjust anything. Okay. Let's see, there we are. So let's go ahead and go to part B. I want you to read over part B-I. Think about it. What would you need to do? Maybe start trying it out. If you want a reminder about average rate of change, go to your key concepts packet, open up to page 3. Under Unit 1A, average rate of change formula is right there in the middle of the page. Remember, average rate of change formula is just our slope formula. So if you remember slope formula, you can use that one as well. Okay, average rate of change. How do we find average rate of change? What's our formula? F of B minus F of A. B minus A. Oh, F of A. However, we don't have F, we have R. So what is it for ours with the actual A and B values? Let's write it with the R, so it would be R of what? What's our B in this interval that they have? There we are, we're back. So again, like I was saying, 0 is A, 3 is B, so it would be R of 3 minus R of 0 over 3 minus 0. Well, we know those values, right? They gave us that before. What is R of 3? That's the end. What is R of 3? Back up at our 2 points. So we could write that in, right? 70.84 minus R of 0 divided by 3. If you haven't done that calculation, please do it in your calculators. Okay, let's see. Jathan, what did you get for that average rate of change? Negative what? 387. Do we all agree with that average rate of change? Awesome. Now, one thing that I would recommend we do is we put in the units. What would be the units for this average rate of change? Now, the units are, we get, so think back to here, we did R of t divided by t. What was the units for R of t? What is R of t again? What is R of t representing? Right here, R of t is the score in points. There's the units. What is t? Months. So, let's see, there we go. So then that would just be R of t is first, it's on the top. So points per month. So that would be points per month. Now, I also want to point out, they actually gave that to us right here, in points per month. They told us the units. That may or may not happen. So we need to be able to go and figure that out. Okay. The last thing that we're actually going to do for today, so this is about where I ended up with first period as well. So I want to do part 2 here, and then we will leave the rest for tomorrow. So part 2 says, interpret the meaning of your answer in context from the problem. We talked about this a little bit last week. We did average rate of change in polar functions. If the average rate of change is negative, what is the function doing? Well, go to that same page in our key concepts packet. Right underneath our average rate of change, it has average rate of change in the behavior of functions. If the average rate of change is negative, what is the function doing? So right there on the 3rd page, it's 4 bullet points altogether. You have different options. Average rate of change is positive, negative, increasing, decreasing. We're in negative. If average rate of change is negative, what is the function doing? Decreasing. It's right here. It's the second one. The function is decreasing. The average rate of change is less than 0. So that's going to be our interpretation. Now we want to write it out with the context of the problem. So we can say, on average, get out of that, get an actual marker. There we go. On average, the group's score, which is R of t, so R of t is decreasing over this range. So it says the group score R of t is decreasing. So there's our interpretation. But let's give that a little bit more context. Decreasing at what rate? The 1.387. So we'd say at a rate of 1.387 points per month. And there we go. There's the interpretation. So, part B, I, you'll be calculating an average rate of change. Part 2, you're probably going to be interpreting that average rate of change. Part 3, we'll have a little bit more to do. But again, I'm going to go ahead and stop there. So, for homework tonight, I want you to get up through that part in the next 2 FRQs that I have in the same packet. One thing I did want to show you real quick, guys, if I could have your attention back here. We have a couple minutes. I wanted to show this, and I forgot to do it back when we were going over it. Is that we on, let's see, on the one where we were finding the average rate of change, we're able to just plug in the values here because they gave it to us. Wasn't that big of a deal. Sometimes they might be asking for intervals of time that were not initially given to us. And so that's why storing the function as we did here in y1 is useful, because I can actually go here. So if I make my fraction, remember I can recall y1. Do you remember how to get y1 on the ty? On the ti? Alpha trace. So I can go alpha trace y1 of 3 minus alpha trace y1 of 0 divided by 3 minus 0. I could also plug it in that way, hit enter. This one gives me a fraction, so all I need to then do is go to math, number 2, change it to a decimal, and is that the same decimal that we got previously? Yes, it is. Okay, so I did want to mention and show that one, that since we stored things, we can use them to recall and find our answers at a later time. Okay, that's what the last thing I wanted to show.